Hello, good day. This is Mathema. Today we are going to talk about variations. I have here four types. Direct variation occurs when one variable increases or decreases in the same ratio as the other. So they go together. If one goes up, the other will also go up. If one goes down, the other will also go down. Our equation is y is equal to kx. K is our constant ratio. Inverse, they go the opposite ways. So it occurs when one variable increases while the other decreases proportionally. So if one increases, the other decreases. If one decreases, the other increases. That's inverse variation. Joint variation occurs when variable varies directly as the product of two or more variables. So basically, when you say joint variation, that is just a direct variation, but we have another variable called z. And then combined variation is a combination of both direct and inverse variation. So occurs when a variable varies directly as one variable and inversely as another. So we have here y is equal to k times x over z. Let's do concept check. When y increases as x increases, so y increases as x increases, what type of variation is shown? That is just direct, they go together. Which equation represents inverse variation? So, is it A, B, C, or D? So, if you're going to go back here, our inverse variation is given by this one, right? So, y is equal to the constant divided by the variable x. So, that is just letter B. Number 3. Which variations involves the product of two variables? So, keyword or clue word is product of two variables. That is just joint. This one, that is joint variation. Number 4, a relationship that includes both direct and inverse variation. So it's a combination, direct and inverse combination combined. Number 5, in the direct variation, y is equal to k x. The ratio y over x is what? So you have y is equal to k x. If we solve for k, k will give us y over x, right? And again, what is our k again? Our k is our constant. So the answer here is A, constant. Number 6, if y varies directly as x and y is equal to 24 when x is 6, find y when x is 10. So it's a direct variation. Our formula is y is equal to k x. Y is 24. So we have 24 equals k. X is 6. So this is just, let me just write 6k. This is just 6k. So my k here is what? 4, right? So my constant is 4. So I'm going to find y when x is 10. So y equals, my k is 4. So 4 times 10, that gives me 40. So meaning to say, if x is 10, my y is actually 40. Number 7. In the equation y is equal to kx, if y equals 18 when y equals 2, determine k. So again, we have y equals kx. If y is 18, so y is 18 equals when x is 9. So we're gonna say 9k. So your k is equal to 2. So if your k is 2, going back again to our direct variation, y equals 2 times, no, we are just asked of the k. So that will be again our answer. My bad. Let's do number 8. Using y is equal to kx with k equals 3, compute y when x is 15. So again, y equals k is 3, x is 15. This gives you 45. Alright, let's do letter C. Number 9. Y varies inversely. If y varies inversely as x, if y equals 8 when x equals 3, find y when x equals 6. So again, our formula here is y is equal to k over x, right? So it says here, if y equals 8, so y is 8. When x is 3, so when x is 3, so you're gonna say x or k over 3. And then we solve for k is just equal to 24, correct? So we know that k is 24. We're gonna find y when x is 6. So we're gonna say y equals 24 over x is 6. So y is just 4. Because again, 24 divided by 6, that is just 4. Number 10. If y is equal to k over x and y equals 15 when x is 4, solve for k. So again, we just simply substitute this one to our inverse variation formula. Y is equal to k over x. We know that y is 15, so we're going to say 15 equals k and then over 4. We just simply cross multiply 15 times 4, that is just 60. So our k is actually 60 and we're done. That is equal sign, by the way. Number 11. When x doubles in an inverse variation, what happens to y? So again, when x doubles in an inverse variation, what happens to y? So our inverse variation again is this. Y is equal to k over x. Now, it is saying that when x doubles, so we're gonna say y equals k over 2x. Because again, x doubles, right? What happens to y if that is the case? What will happen? Will it double? Will it become half, become 0, or stays constant? Again, they are inverse variation. So if x is doubled, what's the opposite of being doubled? It is half, right? So the answer here is letter B. Let's do letter D, joint variation. So again, remember our joint variation is y equals to k x z. It's joint. So it says here, if y varies jointly as x and z, and y equals 60 when x equals 5 and z equals 4, find the value of y when x equals 6 and z equals 10. So first thing to do, we need to find first our constant. So again, we know that y equals k x z. We know that y is 60 equals my x is 5, my z is 4. So that is k times 5 times 4. This gives me 60 equals 20k. So k is just equal to 3. So since I have that, I'm going back again here. Y equals kxz. I'm looking for y. So y equals, my k I know is 3. And then my x is 6. And then my z is 10. So y is equal to 60 times 3, that is 180. So this is our answer. Number 13. Given x, given y equals kxz and y equals 72 when x equals 3 and z equals 8, determine k. So again, y equals kxz. I know that y is 72. K I do not know, but I know x is 3 and I know z is 8. So this is now 72 equals 24k. No, 24k, yeah, 24k. And then what is 72 times 24? That is just 3, right? So k is equal to 3. So again, my answer is k equals 3. 14. If y equals 6x z, find y when x equals 4 and z equals 2. So again, it's a simple substitution. Y equals, constant is k, so 6, x is 4, and then z is 2. So what is this equal to? This is just 8 times 6, that is just 42. So y is actually 42. Let's do combined. So again, combined, going back here, when you say combine, it's a combination of inverse and direct variation. So we have this formula, y is equal to k times xz. So again, we're gonna write that, or is number 15. So again, we know that y equals k times xz. That will be again our combined variation. So here, write the equation for a relationship where x varies directly as x and inversely as um, z. So basically, y varies directly as x, so we have k, x, and inversely as z. So that's it. Or again, you can do it this way, y equals k, x, z. The same thing. Number 16, if y equals k times x over z, and y equals 12 when x equals 9 and z equals 3, solve for k. So again, we're gonna say y equals k, x, z. Y is 12, so we're gonna say 12 equals k, we don't know that. I know that x is 9, so that is 9 over 3. So this is just, I'm gonna write here, this is just 12 equals k. What is 9 times 3? Divided by 3, that is just 3, right? So basically, to solve for k, divide everything by 3. So 4 equals k. So that will be my answer. 12. Use y is equal to k times x over z to find y when k equals 2, x equals 14, and z equals 7. So again, simply substitute. Y equals k is 2 times x is 14 over z is 7. So again, this is just 14 over 7 is 2. 2 times 2, that is just 4. Alright, let's do word problem. So y varies directly with x. So y varies directly. So y equals kx. If y equals 84, so 84, x is 7. So k equals 7. Find y when x is 10. So first we need to solve for k. So what is 84 divided by 7? That will just give us 12, right? So 12 equals k. So since k is 12, we're gonna say y equals 12 times 10. This is 120. 19. The time y needed to finish a task varies inversely with the number of workers. So again, y varies inversely, so k over x. If y equals 12 when x equals 6, find y when x equals 8. So again, 12's y, we don't know the k yet, 6. So what is 12 times 6? That will gonna give us 72, correct? 72 is our constant. So find y when x is actually 8. So we're gonna say y equals, I know that k is 72, then x is 8, so y equals 9. So therefore, the time needed, what is this? What is x again? The number of workers needed to finish the task is actually, no, the time, the time needed to finish a task, no, is actually 9 hours. So the rest is yours to answer. That's number 20, 21, 22, 23, and 24, and 25. Peace.